BJT with the FET, and since the input impedance of the FET is very high, while we are biasing the FET, we don't have R1 resistor here. So R1 parallel to R2 resistance, we are taking the input based terminal. But whenever you are drawing a FET single stage FET amplifier, so CS amplifier consists of only RG base resistance between base to ground. Right? So R2 resistance will not be there. Directly in place of RB, you have RG resistance. The rest of the circuit is same. Right? So when you are analyzing two-stage acid-coupled FET or BJT, the basic step still the replacement of the FET with its equivalent of the H parameter is same. That means first you have to take the AC equivalent of the given circuit, right? So after taking the AC equivalent of the given circuit, to take the AC equivalent of the given circuit, whenever you are having more number of stages cascading to the first stage, that is, if you are having second stage, you are considering the input impedance of the next stage, right? Input impedance of the next stage is considered, and that input impedance of the next stage is considered as the load resistance for the first stage. And then we are doing the analysis. So whenever we are having two stages, whether it is a transformer coupled, RC coupled BJT or RC coupled FET, right? First you have to draw the circuit diagram by with the help of the devices. That is, whether if it is a BJT, you are connecting the BJT. If it is a FET, you are connecting the FET. Then after drawing this, you have to take the AC equivalent. So while you are taking the AC equivalent, the second circuit, the complete second, the complete this set is going to be replaced with the input impedance of this particular FET. So input impedance of FET Ri only we are going to take, right? Ri in case of BJT, two-stage AC coupled, or Ri in case of FET also. Right. So replacing FET with its high frequency model and considering AC equivalent circuit, then simplify using Miller's theorem. We have this. So directly I have taken this. So how I have taken this is, the first thing is, so when you are taking the AC currents at the first stage, the second stage మొత్తం తీసేసి you have to consider here the Ri resistance as a load resistance for the first. Okay, let me draw the circuit. Okay, what you are doing after drawing the two-stage FET, what you have to replace the two-stage FET. This is your RD, drain resistance. This is VDD. Right? Output of this is connected through the coupling capacitor CC, and here we are considering the Ri, that is the input impedance of next stage as the second stage, and then we are considering the RS, CS, and here the RG is the base resistance. So this is the equivalent circuit. Here we are connecting the source. Yes, whenever you are connecting the source, a small RS also will be there. So after that, the first step is you have to replace the second stage, complete second stage, by considering its input resistance as the load resistance to the first stage. Now after this, you have to take the AC equivalent circuit. What is the second step? You have to take the AC equivalent of the given circuit. What is AC equivalent? AC equivalent means whenever you are taking the AC equivalent, you have to ground this, short circuit this source, short circuit the source, and short circuit all the capacitances, right? Short circuit all the capacitances. But we are going to consider whenever we are going to analyze the circuit with respect to the low frequency, mid frequency, and high frequency. Three frequency analysis we have to do. Right? Whenever you are considering the low frequency and high frequencies, right? So we have to consider the capacitance effect. This capacitor CC effect will be there at low frequency, and this CS is going to be short circuited because it is connected in parallel. If it is short circuited, RS is also going to be short circuited. So you are considering the value of CS to be very large, such that whenever the AC voltage is AC current is passing through it, the transistor is going to be short circuit, capacitor is going to be short circuited, and the net effect of RS and CS is going to be shorted. So what is the equivalent circuit we have? Equivalent circuit is RG FET. This resistance capacitor is disconnected, and from the drain to ground is RD, and then CC, and then RI. This is the low frequency equivalent. So we are going to do the three responses: low frequency response, mid frequency response, high frequency response. So in the low frequency, the RSCS is chosen in such a way that for the low frequency signals, in the low frequency signals, the CS is going to be short circuited and CC effect is present. This is your AC equivalent of the given circuit at low frequency. Are they AC equivalent in low frequency? In the mid frequency range, what happens? In the mid frequency range, since the frequency is in between, we are choosing the values of CC, collector capacitor, and CS in such a way that both the capacitors are enters into the steady state. In the steady state, whenever we are applying the AC voltage mid frequency range, in that particular range, both capacitors enters into the steady state. Hence, we are considering both the capacitors are short circuited. So, equivalent దగ్గరే మనకి, if you understand how you are getting the equivalent circuit. So in the mid frequency range, what happens? We are considering both CC and CS are short circuited. Why these two are short circuited? Because both the capacitors enters into the steady state and both are considered as short circuited. When this is short circuited, then the low frequency low, this capacitor effect will not be there. Rest of the circuit is same. Okay? This capacitor CC will not be there. Instead of CC is short circuited in mid frequency circuit. Okay, CC is short circuited in the mid frequency analysis. So CC short circuit and then the input resistance to RG, output RD and RI present. You have to replace the transistor effect with its equivalent. So idantha circuit the same as the set of here BJT. BJT లో కూడా ఇక్కడ RB ఉంటుంది, right? ఇక్కడ అవుట్పుట్ రెసిస్టెన్స్ RC ఉంటుంది, ఇక్కడ RI ఉంటుంది, ఇక్కడ CC ఉంటుంది. Transistor instead of transistor, we are replacing that with the FET. What is the FET equivalent circuit? Consists of equivalent of the FET. FET equivalent circuit enti? FET equivalent consists of input resistance for very high input resistance and is open. This is VGS, gate is input, source is grounded, drain we are connecting the output. So input resistance is very high and it's open circuited. When it is open circuited, complete input is going to be coupled to the output. Hence, dependent source. Here, dependent source is GM, P, G, S. GM, VGS, and then output resistance small RD. This is the equivalent of the FET. At the BJT equivalent number, BJT we are replacing BJT with its H parameter equivalent number. Here, the FET is replaced with its equivalent model, which consists of GM, VGS, one dependent source and one resistor in parallel with the output resistance. So, ఇక్కడ ఈ transistor place లో you are going to replace that circuit with the equivalent circuit. So, the same is shown here. The same is shown here. Here, you see this is VGS is input, RG is the RG resistance. So, in between gate, source and drain. Gate, source and drain. In mood places lo we are going to connect. We are replacing the transistor with its equivalent. Okay, with the high frequency equivalent. As I said, it is high frequency equivalent. High frequency equivalent and time. This is mid frequency equivalent circuit wherein no capacitor effect is there. So high frequency equivalent and high frequency equivalent consists of the capacitor at the input. ఇక్కడ VGS ఉంటుంది, right? In between gate and drain, there is a capacitance which is called CGD. This is called CGS. Next, this is dependent source, GM, VGS, then output resistance RB. Now here ikkada undi the gate, idi input terminal, idi drain output terminal. So in between input and output terminals, this capacitor is a common capacitor between input and output. Like the BJT, the hybrid pi equivalent model consists of empty hybrid pi element base B dash terminal ki collector terminal ki madhyalo resistor and capacitor untai. So these two resistor and capacitor are replaced with its Miller equivalent circuit. Miller resistance replace cheyalante em cheyali? Input lo output lo with respect to the gain we are replacing it. So once you replace the capacitor, the input and output with the help of Miller equivalent circuit, ఇన్పుట్ కెపాసిటర్ ఏమవుతుంది, రెండు కెపాసిటర్, ఈ కెపాసిటర్ రెండు కెపాసిటర్స్ ఇన్పుట్లో ఉన్నాయి, రైట్. సో ఇక్కడ ఇది ఓపెన్ సర్క్యూట్, ఇది ఓపెన్ సర్క్యూట్ కాబట్టి ఆల్వేస్ దిస్ ఇస్ ఓపెన్ సర్క్యూట్. సో వోల్టేజ్ డ్రాప్ అక్రాస్ దీస్ టూ ఇస్ గోయింగ్ టు బి కన్సిడర్ దిస్ కెపాసిటర్ రెసిస్టర్ సిజిడి అండ్ సిజిఎస్. సిజిడి అంటే ఏ ఇంటూ సిజిడి బై ఏ మైనస్ వన్ ఇన్పుట్లో వస్తుంది, అవుట్పుట్లో సిజిడి ఇంటూ ఏ మైనస్ వన్ బై ఏ ఏమో అవుట్పుట్లో వస్తుంది. So these two capacitances at the input and output are going to be replaced with E capacitor. We are going to replace with the input capacitor and the output capacitance, right? C in, C out. Okay. ఇప్పుడు ఈ సి ఇన్ సిజిఎస్ ఈ రెండు కెపాసిటర్లు ప్యారలల్ ఉన్నాయి, బట్ ఎఫెక్ట్ ఆఫ్ దీస్ టూ ఇస్ గోయింగ్ టు బి నల్లిఫైడ్. వై? బికాస్ ఇప్పుడు ఈ టూ టర్మినల్స్ ఓపెన్ టర్మినల్స్ ఉన్నాయి, ఈ టూ ఓపెన్ టర్మినల్స్ ఉన్నాయి కాబట్టి ద ఎఫెక్ట్ ఆఫ్ సిజిఎస్ అండ్ సిఐ ఈస్ గోయింగ్ టు బి నల్లిఫైడ్. ఓన్లీ ది అవుట్పుట్ కెపాసిటెన్స్ ఇస్ కన్సిడర్డ్. అవుట్పుట్ కెపాసిటెన్స్ ఇస్ కన్సిడర్డ్ అట్ హై ఫ్రీక్వెన్సీ. సో హై ఫ్రీక్వెన్సీ దగ్గర ఏం కెపాసిటర్ వస్తుంది? సి అనేది అడిషనల్గా ఒక కెపాసిటర్ వస్తుంది, దట్ ఈస్ బికాస్ ఆఫ్ హై ఫ్రీక్వెన్సీ మోడల్. And coupling capacitor, because we are already connected the coupling capacitor externally, we have another coupling capacitor. So two capacitances in the circuit. అవి రెండు ఇక్కడ మనకి directly have given in the circuit. How we have given the circuit? So replacing FET with its high frequency model and considering AC equivalent circuit, then simplifying using Miller's theorem, we have this. So instead of going ahead with all these three steps, 1, 2, 3, and fourth step is we are going to replace the transistor with its hybrid pi model. Then this is upper model and using the Miller theorem. So these four steps I have avoided and I directly have given this circuit. The four steps are going to be avoided and I have directly given this particular circuit wherein we have GM, RG, input VGS. So transistor replacement, FET is replaced with VGS, GM, VGS and RD. Right? RG our input resistance. This C. What is this C? This is because of the high frequency mode, high frequency Miller equivalent circuit. This C is nothing but high frequency Miller equivalent. This C is high frequency Miller equivalent. And then RD. So RD is the resistance which is connected between drain and the supply voltage. Right? ఇక్కడ నుంచి output. Next stage లో ఉంది CC. This is the coupling capacitor. Coupling capacitor నుంచి RI is connected. We are considering that value is RI. Okay, RI and parallel with RG. ఎందుకు parallel with RG? Because next stage లో RI కి parallel గా RG ఉంది కాబట్టి RI parallel with RG we are considering. అదే in case of BJT, RI parallel to RG, RI parallel to RB ఉందనుకోండి. What is the net effective resistance in case of BJT? In case of BJT లో RI input resistance parallel to RB, దీన్ని approximated to what value? RI parallel to RG. What is the approximate value? ఈ వాల్యూ ఎంత అవుతుంది, ఈ వాల్యూ ఎంత వస్తుంది చెప్పండి. నేను చెప్తాను ముందుకుంటా. RI parallel to RB, RB అంటే బేస్ రెసిస్టెన్స్, R1 R2 parallel కాంబినేషన్ తీసుకుంటే ఇన్ కేస్ ఆఫ్ BJT ఇది. ఓకే, ఇన్ కేస్ ఆఫ్ FET చెప్పండి. ఇది చెప్తేనే ముందుకి నెక్స్ట్ లేకపోతే I want to answer from you. Yes? 78? 310, చెప్పు. ఆన్ చేశాను. 310, tell me. What is the net equivalent resistance of RI parallel to RB? In case of BJT, how much is the input resistance? In case of BJT, input resistance amplifier and the
Very
input
high,
resistance
ma'am.
of the amplifier low na higher?
High, ma'am.
Low. RB value is high. When low value is in parallel with high value, the effective resistance is low. That means what? This is approximately equal to Ri. That is the reason why we have calculated the value of, we have considered the Ri as for the next stage and it continues. In case of FET, Ra value is very very high, it is almost infinity. Ra is infinity, Rg value is low. So effective parallel combination is equal to what is the effective resistance? Low వస్తుంది, which is nothing but Rg. అందుకని ఇక్కడ Rg ని కన్సిడర్ చేసాం. So in the given circuit, ఇక్కడ Rg parallel to Ri కన్సిడర్ చేయాల్సి వచ్చింది. ఎందుకంటే Ri is infinity. Rg is next test set for Rg is also there. So parallel combination of these two will be approximately equal to R1 parallel to R2. Rg ante is nothing but R1 parallel to R2, which value is greater less than the Ri. Hence, effective resistance, load of the first stage will be Rg అవుతుంది. Ri can be neglected. Okay, Ri is infinity, R0 is Rd in case of FET. So gain at mid frequency తీసుకున్నప్పుడు ఈ two capacitor effects ఉండవు. So gain at mid frequency తీసుకున్నప్పుడు you have to remove these two capacitors and redraw the circuit. Okay, ఇక్కడ నేను have not redrawn this, but you have to redraw the given circuit by removing the capacitances. ఈ C ని remove చేయాలి, ఈ C ని short చేయాలి. Okay, when we neglect all the capacitances, what is the gain of an amplifier? Gain of an amplifier is V0 by Vn, which is nothing but equal to V0 by Vgs, right? So V0 will be equal to what? V0 is ఇక్కడ, V0 ఇక్కడ షార్ట్ సర్క్యూట్ అయిపోతుంది. దీస్ టూ కెపాసిటర్స్ షార్ట్ సర్క్యూట్ అయ్యాయి, అన్ని షార్ట్ అయిపోయినప్పుడు V0 ఏమవుతుంది? మిడ్ ఫ్రీక్వెన్సీలో ఇది షార్ట్ అయింది, ఇది షార్ట్ అయింది. ఈ కెపాసిటర్ షార్ట్ అయింది అంటే అర్థం ఏంటి? ఆర్డి, ఆర్డి, ఆర్జీ, ఆర్ఐ, ఆల్ ద రెసిస్టెన్సెస్ ఆర్ షార్ట్ సర్క్యూట్. అంటే ఇది షార్ట్ సర్క్యూట్ కరెంట్ గెయిన్ అయిపోతుంది. ఇది షార్ట్ సర్క్యూట్ ఏంటంటే అవుట్పుట్ వోల్టేజ్ V0 విల్ బి ఈక్వల్ టు వాట్? జిఎం విజిఎస్. అంతేనా? జిఎం విజిఎస్ ఇంటూ ఆర్. సారీ, you have to consider the effective resistance equal, the series resistance short అవుతుంది, ఈ resistance open అవుతుంది. Then output V0 will be equal to GM VGS into all these resistances. So this RD parallel to RD, parallel to RG, parallel to RA. Okay, so RA value is since very very high, the effective resistance is parallel combination of these three, which is V0 will be equal to minus GM VGS into R అని రాస్తే చాలు, దాన్ని మళ్ళీ విడగొట్టాల్సిన అవసరం లేదు. So this is the gain of an amplifier. Okay. At low frequency, what happens? Low frequency దగ్గర high frequency capacitive effect will not be there. High frequency capacitive effect will not be there at low frequency. Hence, this is eliminated. This is open circuited, and this capacitor, coupling capacitor is present. CC is present, and that is not present. And since we know that Rg parallel to Ri is effective resistance is Rg, consider only Rg value here. Only Rg is connected. Now, take the value of V0. So V0 will be equal to what? V0 will be equal to this applied voltage multiplied by the effective resistance. We can say it as Z. Okay, so how we are calculating this value of Z? That is, we require to calculate the V0 equal to I0 into Rg, or what is the value of I0 at GMVGS minus GMVGS into the effective resistance of total effective resistance. We can take that in that way. So Rd parallel to Rd ni, I'm writing this value of Rd parallel to Rd only. ఇవి రెండు సిరీస్లో ఉన్నాయి అనుకోండి. సో ఇట్ ఈస్ Rg plus 1 by G omega Cc, Rg plus 1 by omega Ccd. This is Rg by 1 by omega Cc. Okay, so the I0 output current will be equal to applied voltage minus GMVGS into in మూడు parallel branchలో నేను ఒక బ్రాంచ్ ఇది ఒక బ్రాంచ్ అని తీసుకుంటే I want the current drawn in this particular branch. అప్పుడు ఏం చేస్తుంది? అపోజిట్ రెసిస్టెన్స్ divided by sum of the resistances. So opposite resistance అంటే Rd parallel to Rd. So minus GMVGS into Rd parallel to Rd divided by sum of the resistances. So Rd parallel to Rd plus Rg plus 1 by G omega C. This is I0. Next, V naught equal to I naught into RG. Just simplify this equation and multiply with RG. Then you will get simplified value. You have to simplify this in terms of, as I said, you have to simplify the given circuit. Like in the denominator, you should get 1 plus j something. Denominator is 1 plus j something randomness. In the denominator, you should get a complex number wherein you should represent alpha plus j beta. Right? Alpha plus j beta generally will make it equivalent to be 1 plus j beta. So the 1 plus j beta avatarity resistance I have rearranged the values of resistances and I've rearranged this and I got this value as uh, this is a constant divided by 1 plus j beta. Now to get the gain, gain at mid frequency will be equal to gain at mid frequency, gain at low frequency will be equal to gain at mid frequency divided by 1 minus j FL by F. Same as the BJT. BJT lo kuda you got the final value of this where FL will be equal to RD plus RD by 2 pi CC into RD RD plus RG RD plus RG RD. So this is the gain at low frequency value. Okay. So now after finding the gain at low frequency, we have to consider the magnitude and phase. Then these two values of magnitude and phase are calculated mid frequency. So at high frequency, what happens? At high frequency, this capacitor is short circuited and this capacitor C is present. So CC is short circuited and the given circuit, the CC is short circuited and capacitor C is present. And C is present. Next, ఇక్కడ ఏంటి అన్ని parallel combination కాబట్టి just have taken the values of parallel combination of RI, RG, RD and RD as parallel combination. So AVH gain at high frequency will be equal to V0 by Vs, V0 by VGS. So V0 value equal to minus GMVGS into Z minus EVF into Z, where Z will be equal to R parallel to XC. ఇదంతా R అనుకున్నాం అనుకోండి 1, 2, 3, 4 రెసిస్టెన్సెస్ ఉంటాయి. Whenever you are having no number of resistors, RC network simplify చేయాలంటే first you have to take the equivalent of all the resistances. సిరీస్లో ఉన్నాయా parallel ఉన్నాయా? Get the effective resistance. Then add the capacitor and then resistor. Otherwise, it will be difficult with by handling 3 different loops. Loops 1, 2, 3, 4, 5 loops. So loop equations is a design చేయడం కష్టం అవుతుంది. ఈ design equations వేసి చేయడం కష్టం అవుతుంది కాబట్టి and moreover all resistors and capacitors are parallel with each other. Just simply first verify the effective resistance. Then the parallel combination of effective resistance with the capacitor gives you the net effective impedance. R parallel to 1 by j omega c. So R into 1 by j omega c divided by R plus 1 by j omega c considering for the net effective resistance. ఇక్కడ net effective resistance R in parallel to C, R into 1 by j omega c divided by R plus 1 by j omega c. దీన్ని simplify చేస్తే you will get R by 1 plus j omega c. This is Z. So I naught will be equal to minus GM and GM. V naught will be equal to I naught into Z. కాబట్టి V naught will be equal to minus GM R by minus GM VGS into R by 1 plus J omega C. ఇది చాలా సింపుల్. హై ఫ్రీక్వెన్సీ మోడల్ సింపుల్గా వచ్చేస్తుంది బికాజ్ ఇట్ ఇస్ ప్యారల్ కాంబినేషన్ సింపుల్గా వచ్చేస్తుంది. Now after find gain and phase. Always have to remember that J term వచ్చినప్పుడు J term ని కంపల్సరీగా 1 plus J omega C ఫామ్లోనే రాయాలి. So once you get this as 1 plus J omega J 2 by FCR, we are replacing the we are using the magnitude and phase expressions for this and then we are calculating the gain and magnitude, gain and phase shift. Is it clear? You have any doubts in this? No, any doubts. You have any doubts, you can ask. ఏమైనా ఇంకా ఒకరు వెళ్ళిపోయారు 66 Srija left, Shruti left. What happened? Hello.